All right, we're in as Brandon here, people. That was very, very easy. So first thing that I want is, of course, I want to know what memberships am I part of. So let me open a terminal. Hello, everyone. Welcome to IT Security Labs. And this is our first attacking Game of Active Directory lab video. So our main goal for the day is to end up exploiting this lab environment here, which is a Game of Active Directory by Mayfly on GitHub. This is a vulnerable Active Directory lab, and you can set it up using my videos or some instructions from this GitHub page here. So if you have not done so, Game of Active Directory is a simple to set up lab, and then we can start the attack. So today is a fun way. This is my simplified network diagram where I have an OpenSense firewall in my lab environment, and also I added an elastic SIEM. So these machines here are part of an Active Directory environment, and they're sending logs to the elastic SIEM solution here. So what does that look like? Well, first, this is the Active Directory forest. It's 3 domains that have trust set up. We even have MySQL set up here. So this is going to be very fun to attack and break into. And in this video, we're actually going to get initial access into this domain. In addition to that, we added elastic SIEM. So all the machines are actually reporting, as you can see here. These are the most active agents. These are the 5 machines in our Game of Active Directory environment. You can see the type of information that we're getting. But they're all being managed by Fleet, and my Fleet is healthy. So this is endpoint detection and response, elastic EDR. As you can see, they are happy, and they're reporting in the last few seconds here. So these are some checks to make sure that things are working. And finally, in the last hour, we have not had any alerts. So before we start attacking, things were clean. I'm curious, how is this going to go once we start running Nmap in a little bit here? So all this is just endpoint detection. There is no network detection yet. We might add that, but I don't want to complicate things. What that means is if we're going to run Mimikatz and any of those funny tools, they need to bypass EDR. And that's where the fun is going to be for us. If you want to do this lab, it's super simple. You can follow along with the mind map that they provide us as well. I'll link it down. You can also follow using the full walkthrough for the lab. I'll be using part of this walkthrough, but not everything. I just want to have a little bit more fun, but I'll be using some commands from here. For example, right now we need to start with an Nmap scan. According to the diagram that we have here, the mind map, pentesting Active Directory, we have no credentials, we just some information. To make this fun, I created a statement of work. So our company that hired us is called Trevor Phillips Industries. It's a reference to Grand Theft Auto 5. For those who play, you know what this company is. It's in the exports and imports, more than that, but it's a fun company to have hired us here. They gave us a network diagram, so this is not a black box pen testing or anything like that. It's almost like a white box pen testing. They gave us access to the network. So we have a host on the network. For those who are going for the OSCP, or you're doing a black box pen testing, assume maybe you landed on a Linux box on this network, and now you are using proxy chains or something to pivot and scan the network. It's still the same thing. So they gave us a list of IP addresses here. We don't know the names of the IP addresses yet. This is almost similar to what happens on the OSEP when they give you IP addresses and say, go and find out things. So that's why I like this one. It reminds me of my recent OSEP passing. And here they said, hey, we need to do a thorough reconnaissance. So we are allowed to do that. We need to give them a list of vulnerabilities that we find. So we need to document things. Unlike back in the day when I was doing CTFs, I'll just do things and not document. That doesn't fly in the real world. So we're going to document our work here. The real world, things have to be documented. Then we need to exploit and do some post-exploitation, and of course, reporting. So as long as we have documented everything, a report should be easy to come up with. We need to be able to suggest some fixes to these things. Okay, so that's just a quick intro. Now, let's go to initial access. We're going to start with recon. Let's do an Nmap scan. So I'll go to my YouTube folder. So in here, this is where I'm going to run my Nmap scan. So I'm saying, hey, Nmap, can you reach out and do a service version SCSV, meaning use default scripts, do a service version scan, do a no ping, do not ping, but some machines are set up to not respond to ping. -pp is saying go and scan all ports, in this case all TCP ports, the 65,000 ports. Then OA, meaning output it to a file called all types of output to a full scan all. Then we'll do 192.168.56.10 to 12, then 22 to 23. You can find this as well in the guide here. But I'll also add something like -vv, so I can also see the output as it's going, so I can track the progress. All right, so it's finding ports already. I can see that we are finding ports that are consistent with Windows host. So this is our very first Nmap scan. Another tool that I like to use is called AutoRecon. AutoRecon will do all the work for you. I won't run it here because it automates things way too much to the point where it might take away from our learning on YouTube. But I encourage you to use AutoRecon. Okay, so if we had our intrusion detection system enabled here, we would be catching up all the Nmap scan. But in our OpenSense firewall, I did not have it enabled. I didn't want to do too much. And we cannot see it here because the Elastic SIEM does not have visibility to network traffic. All right, so our results are out. We have all the Nmap scans here. All right, so with our full Nmap scan, I can do a less full nmap scan.nmap. So first, we see that for our host 10, we have port 80, which is HTTP, Microsoft IIS. We also have DNS. We have 88. The moment I start seeing 88, I know this is a domain controller most likely. And then LDEP, yeah, then that's it there. Here we have a kingslanding.7kingdoms.local. This is on 10. So we need to find a way to see if we can break into 10. All right, we also have 445 and all that stuff. Okay, so let's focus on the first host that is on our list right now, which is, in this case, this is a domain controller, 10. They have a port 80 open. Most of the time, this will be the place to go to. Kind of weird to see port 80 open on a domain controller. But hey, who am I to judge? They're just running a regular IIS page. We might even find out if they're running a real website here by running derb. This is just a quick way of just seeing, hey, are they running something interesting? Okay, from here, I can see that they're running a cert server. There's a certain row. If we get desperate, we know we can mess with the certificate stuff. But for now, there's a machine that I did on Hack the Box that actually shows how to exploit certificate servers. So that's going to be cool. I'll pursue it at a different time. But going back here, so scan, find a DC. Well, we already found a domain controller. We can use enum for Linux to find some users on the domain. Then we can maybe move to roasting some users. So I'm going to not do any of this stuff. I need to find out who are the users that are there, so that at least I have some initial access. With a user account, it's actually easier. So let's use enum for Linux for that. Okay, first let's start with 10. Hey, enum for Linux, can you tell me more information about this machine? Ooh, this one does not like to talk to us that much. Let's go to the next DC, which is, this was 10. Now let's go to 11. This one talks a little bit. Oh, this one talks way more. Okay, so we moved on to the second domain controller. So here's what I would do. I would say enum for Linux. Then I'll say -11, just in case I run it on 12.txt. So in the same folder where we ran Nmap, since this is part of enumeration, run enum for Linux on 11, and we're outputting the file called enum for Linux 11.txt. That way we have our results. And from our results of enum for Linux, we saw that there are some users, so we'll find out. Let's enum for Linux. Okay, so according to this, we found some users with the descriptions. Oh, here. Password. We also have a password here. I wonder if this is a valid account. So sometimes they will have passwords in the description. I just happened to run into this. So let's copy that. In my Obsidian here, I'm going to say enum for Linux against .11. Okay. I'm not going to put the results here because they're already in my curly. I can move them later. Then we found creds. I'll just copy it the way it is right now. According to this two enum for Linux, it tried to look for the regular users. Then if we go down here, we see that the domain is north. Found accounts. I guess I'll just copy these ones here. Okay, so here is the list of users that we found. Let's clean them up. I'm just using Atom. You can use grep or whatever. I'm more of, here I want to do things fast. All right, so we have a list of users here. This is going to be bash, just in case. Okay, so we found some users using enum for Linux. Now what's next? Let's keep scrolling down. We also can find password policy. Maximum password history is 54. Minimum password length. This is very important information, especially when we end up creating users next time. This looks like they did not change anything here, which is kind of cool. Nobody has timed out. Minimum password age. And the lockout policy. Lockout threshold is 5. Oh, that's good, because when you brute force, we know that we can do it a couple times. All right, so here's all the users. And some groups. This might be useful information later, but for now, I'm not even using it. Okay, set publishers. That's a good group to think of. DNS admins across the sea. That's an interesting group name. I would like to go and check out what that group is all about. All right. After this, we found some users, right? We can go here and do a password spray, or we can go and do an S roast. So let's move on to the second phase. We have a list of users. There's more we can do here, but I want to move on. Instead of doing a password spray, let's try to do some roasting and see if we can get some users. And here they have commands on how we can do it. For S rep roast, we can go and find out more information about that. So going to Hectrix here to learn more about S rep roast. Let's go and read more about it before we start running commands and getting too excited. The S rep roast attack tool looks for users without Kerberoast pre-authentication required attribute. So there's a box when you set up Active Directory where you can say, do not do any pre-authentication checks. And that means that anyone can send an SREP request to the DC on behalf of any of these users and receive a response back. And this will contain the user's encrypted data that contains their password. Okay. And using this message, the user password could be cracked offline. Furthermore, no domain account is needed to perform this attack. So as long as we have a list of users, and if one of these users has pre-authentication enabled, we should be able to get their password hash. And this is assuming that we are using PowerView. Using Linux, we can use this tool here. First, we need to specify the domain, give them the user, then they specify the format. I use domain creds, extract target machine. We do not have domain creds. So first, try all the usernames in usernames.txt, or we don't have usernames.txt yet. So first, we have our users here. Let's add them to our curly as usernames.txt. Nano usernames.txt. And here's the usernames. Most likely, we can't find like service accounts, but we don't care. We're just going to spray everybody that we found. This is just on one domain. Okay. Now that we have usernames.txt, let's go back to our instructions here. We need to run this in-packet too. So let's locate it and copy it. In-packet already comes with get np users file. Okay, as you can see, I've used it before. Oh, so it's also in user local bin. So I can actually just run it. I can run it from anywhere. It's in my path. That's good to know. So let's copy the command that we have here. And this is how I know how to do things. I find instructions. Then I copy that to my instructions. And I say AS. This is the template. Our domain is not Jurassic Park. We need to change this to our own domain. So let's search for 192.168.38.11 or 192.168.56.11. So that's what we're searching for. Here are the results. So this is the machine that we are after. The domain itself is called 7 Kingdom. And this is the common name, winterfell.north.7kingdom.local. So the domain for us is going to be 7kingdoms.local. So instead of Jurassic.park, we'll put 7kingdom here. User file is called usernames. Output is going to hashcat. Out file hashes.srep. I don't change anything there. Then I'll run that. But remember, it's in my path. I don't need to call Python for that. It knows it's in my path. It should use Python automatically. But if you don't have it in your path, you probably need to do that. All right. First error. What's happening here? 7kingdom.local, user file, usernames, format. So it's saying error 7kingdom. It's actually unable to resolve this. So we need to tell it where 7kingdom.local is so that things can actually work. Nano, /etc, host, add 192.168.56.11 there, and add here north.7kingdom.local. It's going to go to 11. I also just tell it that this is also where 7kingdom.local is. Control X, Y, enter. Get npusers.py. Our domain is 7kingdom.local. We are using a user file, the text. Our machine was north.7kingdom.local, so that's our actual domain controller. The format is going to be hashcat. Want to output it to a file called hashes.srep, and this will actually just extract the hashes themselves. And this is good. So running that, you'll notice that we get these results. But if you say less our hashes file, you notice that we have Brandon here. I actually ran this a couple of times. So that's why this hash, wait a second, Brandon star north 7 kingdoms. These different hashes, or this is the same hash? That's interesting. I got 2 hashes, same type of hash, Kerberoasting. What's happening here? If you know about what's happening here, let me know in the comments. I have no clue why I got 2 hashes. I just ran it a couple of times. Maybe let me run it again. See if I get it again. Okay, so those are the 2 hashes that we have. Next, what is it? Is this saying? Okay, we got the hashes. Okay, we are not using that. So to crack, we just say John. Where list is goes to password. The text. We don't have that. Our word list is going to be, what is that called? Roq.text. So now for us to crack, we use hashcat-m 1800. Then we need to give it the name of the file. It's hashes.srep. We're using user local Roq.text. By now we should have a list. That one done. Okay, it's trying to crack. This might take a while depending on how many resources you give. My color is kind of nice. As you can see, this is the server stuff. So let's have it try to crack the password for our user. And as usual, while that is happening, let's go check out here. Did we get anything interesting? Did you see anything in the last hour? As far as the network stuff is concerned, we didn't. What about on our alerts? I mean, we're scanning. This is where the network people need to start working on their stuff. So we don't have any real alerts here because we haven't interacted with the host or did anything on Windows that's intrusive. So far, everything that the domain controllers are seeing is known as normal traffic. Kerberos is a normal process that runs on Windows. So Kerberos interaction queuing for users is not abnormal for it to generate alerts here. There are actually ways you can use to find out, but that's different. Wait a second. So we have hashes that were different that are going to the same thing. I see dead people. Brandon.stack sees dead people. So let's go and add Brandon's notes. Here we found creds, right? So let's add Brandon. The password is I see dead people. So now that we have credentials, our mind map might be of help here. It will tell us like what we can do. GOAD valid usernames. And then what's next? We crack the hash. Then we will go to this box up here. Got an account in the domain authenticated, clear text pass or whatever. So now we can see what we can do. We can get all the users using crackmap exec, and here's the syntax. Using the username and password, which I think is kind of cool. Or we can use get AD users, DC user, and username. We can do that. We can enumerate SMB shares. We can exploit things. We can run Bloodhound. We can run Power View. There's so much we can do here. So, but we have a valid account for Brandon. Right now, I'm going to just see if XRDP will let us in. I wonder if does Brandon even have remote desktop and what permissions does Brandon have? I'm dying to see that. Then we can get all the other users later, if whatever. But we have RDP open. Can we get in? And if we can, maybe we can run everything directly there. And so what this is happening is the tool called XRDP will go to this machine here with our user Brandon and the password. We're ignoring the certificate so that it doesn't prompt us. We want clipboard so we can copy paste. The resolution is dynamic so that we can see a full screen. And then here, we're sharing my temp folder from my Kali, just in case I need to move files between. I can share any folder that I want, but temp is fine for now. Don't do this in production, otherwise people will hack you back. But in my lab here, this seems to work. Let's see. Yes, XRDP is trying to reach in. It's Brandon. It's waiting for user profile. So this user needs to be added to the RDP allowed users. Most of the time, not every user is allowed. But of course, for our domain here, it looks like it's working. So I will maximize this. All right, we're in as Brandon here, people. That was very, very easy. So first thing that I want is, of course, I want to know what memberships am I part of. So let me open a terminal. If I'm an administrator, then this is going to be fun. I can run Bloodhound and net user. Okay, so here are the users that are on this machine. Looks like a family affair to me. Nepotism, anybody? No, they are running a family business. Net user, Brandon. .stack. This is us. Such group or groups. Such O. Give me everything that you know about this user. All right, Brandon here, local group memberships. Unfortunately, what is this local group membership? What is this stack group? We're part of this stack group. We don't know what that is. We're also part of domain users. Everybody's part of those. Last log on with that. Okay. But net group. Here are all the members. Everybody here is part of the stack group. Okay, so let's run the command prompt as an administrator. All right. No, we can't do that. Okay, so we are a regular user and we're also part of the stack group. We don't know what that means entirely, but at least we have access to this machine. So next we need to either escalate our privileges from just this Brandon user or find other users who might have better permissions. One way or the other, we'll do that. And we'll move on that in our second video. Otherwise, thanks for being here. So far, we've broken in. I hope you're enjoying this. And if you are, please like, subscribe, and share my videos with others. I think these ones are very helpful for everybody who wants to learn Active Directory attacks, including OSCP, PNP, T, OSEP, whatever. This is so much fun. Otherwise, see you later.